Hello student, today we are going to see class 10 physics. It's a very important concept for the board exam. Okay, it's a last minute revision. So I'm going to cover most of the important topic from the physics. Okay, the first thing, mirror. Okay, you need to know mirror formula. 1 by f is equal to 1 by v plus 1 by u. This is a mirror formula. The next one, magnification. M is equal to h2 by h1 or minus v by u. F is a focal length, v is a image distance, u is a object distance. h2 is the image height, h1 is the object height. V is a image distance, u is a object distance. Okay, here minus no, here plus will come. Whenever in between plus is there, here will get minus. In case lens formula, here minus will be there, magnification will be plus. Okay, again the next important thing, lens formula, 1 by f is equal to 1 by v minus 1 by u. See here, opposite. Then magnification, m is equal to h2 by h1 is equal to plus v by u. Very simple. Okay, next one. There are two types of lens and two types of mirror. Okay, convex lens, concave lens. Convex, concave. Okay, for a mirror, this is going to be called as a convex mirror, this is going to be called as a concave mirror. Okay, now according to this, the focal length for this is positive and this is negative. Concave lens is negative. Convex mirror, no, positive. Convex means always positive. Concave means always negative. Okay, it's a name to negative optical device, no. Concave lens and concave mirror. Concave lens and concave mirror. Okay, next. If in case plane mirror, okay, plane mirror, the object is placed in front of plane mirror, no, the image will be formed like this. Okay, magnification is equal to plus 1. What is this meaning? Upright, virtual, erect, same size. Whenever you got magnification is plus, upright. 1 means same size. Okay, image and object height will be same. Upright, virtual, erect and same size will be there. Okay, and also upright image always real image. Okay, this is going to be a real image. Okay, next one. Next one. For a lens, when it will produce upright, virtual, erect and magnified. I am doing only the important condition for class 10 physics. Okay. For a mirror, no, upright, virtual, erect, diminished image. Okay. The object is placed like this, parallel ray will reflect away from the focus. The ray which is incident at here directly reflect back. So image will be formed here. Upright, virtual, erect and diminished image going to produce. Okay. Same thing for concave lens also going to produce with the same image, upright, virtual, erect, diminished. Very important condition. Okay, here F, here C, here F, here C. Okay, so object is placed anywhere between infinite and the optical center. Okay, parallel ray will be reflect away from the focus, center ray and deviately goes straight. Here also image will be upright, virtual, erect. This question, the many chances is that you can get this kind of question. It's a very important condition. Magnification is almost, it is positive because it's a virtual. And the range is going to be 0 to 1. Example, magnification is equal to 0.5 plus 0.5. Upright, virtual, erect, diminished. Plus 1 is representing, plus is representing upright, virtual. 0.5 it's representing as a diminished. Okay. This condition we can get, many chances is there. Okay. Next one, magnification is equal to minus 1. So I'm going to cover most of the important topics physics. If you are listening this class, I think you can get a few marks from these topics. Okay, I'm discussing only the most important topics. Okay, magnification is equal to minus 1 in case I got. Now if asked you to draw the diagram for mirror condition, no, like this, F, here will be C. Object exactly at C, no, parallel ray will be focus and focus ray will be parallel. Inverted, real and same size will produce. Magnification is equal to minus 1. It is a concave mirror. Okay, very, very important condition. Already we got an exam also this kind of question. Same thing. For lens, convex lens also going to produce the same magnification. This is a logical question. Okay, you need to know answer. I hope you will be knowing all the basics. Okay, the parallel ray will go through the focus, center ray will go like this. Inverted real image will be produced when the object is placed at C. Okay, this focal length, concave focal length is going to be a negative. Convex lens focal length is going to be a positive. And this magnification is going to be -1. What is minus? Minus indicating real inverted. One is representing same size. So both the condition is going to produce with the same. Inverted, real, same size image going to produce. Okay. Next one. Refractive index. Okay. Refractive index. Refractive index according to Snell's law, when the light is traveling first medium to second medium, sin I by sin R. Incident angle by refracted angle. Same formula, velocity in a first medium divided by velocity in a second medium also we can write. Same thing, refractive index of glass with respect to the air. Light is traveling air to glass. Velocity in a first medium by velocity in a second medium. First medium is the velocity of the light in a air. Second medium velocity of the light in a glass. This ratio also. This is going to be called as a refractive index. Okay, one more thing I want to say. When the light is traveling one medium to another medium, the quantity which is not going to change. The quantity frequency is not going to change. Velocity wavelength going to change. When the light is traveling one medium to another medium, velocity and wavelength will be changing. Frequency not going to change. Okay. The next one, when the light is traveling one medium to another medium, it deviates towards the normal. No, it's a rarer to denser. In case it deviates away from the normal, okay, it's going to be a denser to rarer. Opposite condition. It's also very simple. Okay. Then what is absolute refractive index? Absolute refractive index, no, always will be the value greater than 1. It has to travel always the rarer to the denser medium. In case if you are getting denser to rarer, that's not going to absolute refractive index. Your answer must be more than 1 for refractive index. Okay. It has to travel from rarer to denser medium. Okay. Now next question. Power problem. Power is equal to 1 by focal length. Power is inversely proportional to the focal length. The unit of power is diopter. Example, I am taken focal length is 50 centimeter. What is the power? 50 centimeter we can call of meter. So power is equal to 1 by focal length. So 1 by 0.5. So 10 by 5. 2 diopter as a power. It is a convex lens. Okay. Example, next one. Power is equal to -4 diopter. What is a focal length? Focal length is equal to 1 by power. So minus 1 by 4. 1 by 4, it's going to be 0.25. So it's going to be meter. So 25 centimeter as a focal length. Okay. Like this you can calculate as a opposite way. Okay. Next one. Recombination diagram, spectrum and dispersion. We are taken as a prism. When the light is traveling from the light is traveling like this, monochromatic light. Okay. Monochromatic means it's not going to make any dispersion. Okay. In case if you are taken as a polychromatic, it will get dispersion. I am taken monochromatic light. This is the incident angle. This is a first deviation. This is refraction 1. And like this, it will come like this. It will be a emergent and it will be a total deviation. And this is the angle of the prism. Okay. When this question is asked in exam, many of them will get confused. It's a very simple. Draw like this prism ray, like this. Okay. Like this you will draw. Then 4 important point. I, A, E. Incident angle, emergent angle, angle of the prism. Then this is a deviation, total deviation. Okay. And if you know, then you will go this. Okay. If you can make any mistake means don't write this also. This is a diagram for the prism. One more thing I want to say about the prism. When base and this ray, it's parallel, no. That time I is equal to E, R1 is equal to R2. The deviation will become minimum. Okay, it's a special condition. Okay, only at this particular point, BC and QR, refracted ray, QR. When it's become parallel, that time only this is going to happen. This and this parallel, this will be happen. Okay. We will take it as a white light. When the white light is getting travel to the prism, it will get dispersed with the 7 colors WebGR V I B G Y O R. Red deviate least, violet deviate most. Why violet deviate most? Because violet travels slower in the glass, red deviate faster in the glass, and also the wavelength of the red is greater than the wavelength of the violet. That is the reason the red deviate least. It's a very important question. Okay, next. I am discussing only the most important condition and a revision. This is a revision class. Okay. Next one, electricity formula. If you know the formula, if they ask problem, at least you can write the formula. You will get 1 mark for that problem. Okay. Electricity formula. Define current. Current is the rate of flow of charge. Then the unit of current 1 ampere is equal to 1 coulombs by second. Define voltage. The voltage is equal to work done by bringing charge from infinity to one point potential. Same thing, work done per unit positive charge bringing from one point to another point, it's called potential difference. Okay, potential and potential difference. The unit of potential we can call as 1 volt is equal to 1 joule per coulombs. This also it's a very easy. Okay, 1 volt is equal to 1 joule per 1 coulombs. Okay, next one, what is Ohm's law? Applied potential difference. Relation between these two. Applied potential difference is directly proportional to flowing current. If you remove directly proportional, you will get the resistance constant. R is equal to V by I. The unit of resistance ohms, volt by ampere. Okay, so it is a Ohm's law. In case they asked you to verify the Ohm's law, verification of Ohm's law, you draw simple circuit plus minus like this, key with rheostat. Rheostat we can call as a variable resistor and voltage controller, ammeter and resistance and voltmeter. Voltmeter always connected in parallel, ammeter always connected in series. Okay, the next one, factor affecting resistance. What are the 4 factors? The first one, length. Second one, area. Third one, nature. Fourth one, temperature. Okay, first we will see how it's going to affect. Resistance directly proportional to length. More length will offer more resistance. Area is inversely proportional. More area will be offer less resistance. Nature, good conductor have less resistance, bad conductor have more resistance. If the more temperature, going to offer with the more resistance. Okay, now the resistivity derivation. Resistance directly L, inversely A, which we know already. If you remove directly, you will get as a resistivity. It's a very important 3 mark question. L by A. Whenever you remove directly proportional, you should include the constant. Here constant is called resistivity. If you want what is resistivity, take area this side, length this side. So RA by L. Unit of resistance, ohms. Unit of area, meter square. Unit of length, meter. So resistivity unit is ohm meter. The next one, conductivity. What is conductivity unit? Conductivity is inversely proportional to the resistivity. So you will get as a ohm inverse, meter inverse. Next one, energy formula, VIT. Vellore Institute of Technology. Like that also you can remember. What is V now? According to Ohm's law, IR. V is IR. V is IR. Substitute here. I square RT we can get. I square RT. Again I is equal to V by R. So V square by R into T. This is the energy formula. If you want power, power is equal to energy by time. Remove all the times. VI. I just remove the time here. Here I square R. Here V square by R. So this is a power formula. The next one, what is 1 kWh, kilowatt hour, which is called commercial electrical unit, 3.6 into 10 power plus 6 joules. Okay, next one. For next one, magnetic effect of electric current. It's a very simple. Okay, it's first thing you need to know what is the properties of the magnetic field and bar magnet. Okay, So north to south magnetic field will be passing like this. Okay, this diagram many times is asked in the exam. The magnetic field start from north pole, end with south pole. Okay, so outside the magnet like this you should draw. Okay, even solenoid coil also is asked in a many times. Okay, in this chapter is a very simple. They will asking only, they will ask you to draw the magnetic field around the solenoid coil and around the bar magnet. Bar magnet will be easy. Solenoid coil you need to focus little bit, then only you are able to understand. Same like a bar magnet only, but lot of students they making mistake here. Okay, you have to be very careful when you are drawing like this type of thing. It's not going to intersect. North to south, the magnetic field start from north pole, end with south pole. It is outside the magnet, inside the solenoid coil, south to north. Okay, magnetic lines never intersect. It is a vector quantity. The unit of magnetic field we can call as a Tesla. The space around the bar magnet we can call as a magnetic field. Okay, it is the lines never intersect. Okay, the closed line will offer this more magnetic strength. So here magnetic strength will be more. Okay, like this means the magnetic field will be weak. Okay, that is a few properties of the magnetic field. Okay, next one, right hand thumb rule. Right hand thumb rule. Right hand thumb rule, my thumb is representing as a current direction, finger is representing as a magnetic field direction. Rules also you need to know from this chapter. Okay, right hand thumb rule. My thumb is representing as a current direction, my finger will be representing as a magnetic field direction. Okay, so in case wire is like this means the magnetic field, circular magnetic field will be produced. You should use right hand thumb rule to find the magnetic field direction. Okay, next one, Fleming left hand rule. Fleming left hand rule, FBI, force, magnetic field and current. Fleming right hand rule, FBI, force, magnetic field and current. Okay, left and right both will be same. I'll do only left. Okay, left is used to find the force direction, right is used to find the current direction. FBI. Okay, force unit Newton, magnetic field unit Tesla, current unit ampere. This three is mutually perpendicular. Okay, there are three rules: right hand thumb rule, current and magnetic field will be representation. Fleming left hand rule, FBI, force, magnetic field and current. Fleming right hand rule, FBI.